You're all very welcome to this Engineers Ireland Midlands Region lecture this evening. The title of our lecture this evening is Pavement Assessment for Pavement Asset Management and Rehabilitation Proposals. So this presentation aims to inform those who are carrying out rehabilitation designs and asset management based on a range of structural and non-structural pavement investigation techniques typically applied on national, regional and local roads in Ireland. And our presentation this evening is being given by Seán Clancy. Seán is a graduate of NUI Galway and a member of the Institute of Asphalt Technology with 12 years experience in pavement assessment with expertise in structural pavement evaluation and FWD assessment. Seán is an engineer with Westmeath County Council and was formerly employed as Senior Project Engineer with Pavement Management Services Limited. Seán has experience in designing structural rehabilitations for a huge range of road pavements throughout Ireland and the UK and for airport pavement in numerous locations across the world. So without further delay, I shall hand you over to Seán, and thank you very much, Seán.
Thanks, Jean. Thanks, everybody. So I'll just crack on, and just as I hit my first slide, I'll also make reference to an excellent course that Engineers Ireland are running with TII, ARUP and TU Dublin. It's the Design and Life Cycle of Road Pavements course, and anyone who's working on pavements in the country really should be doing it. What I'm about to touch on here is only the cusp of what they're doing, and it is definitely worth doing. Anyway, so the role of pavement, we're all familiar with it, we all use it daily, and how do we consider our own usage of it? So what it does for us, it provides a safe, even and consistent, reliable surface for vehicles and other road users to travel on. It provides us with friction for movement, but also for braking. And what we kind of have to be conscious of as well is that while it's protecting us from the environment around us, we're also protecting the subgrade, and the environment is being protected by the pavement from the loading from vehicles. So it needs to be a consistent load-bearing structure. So in terms of, as you as the asset manager, oh, I'm missing a slide there. What is the pavement to you? So the pavement is your asset. And you have to be conscious of, while the TII might hold the purse strings and manage, you as the county council engineer, the asset really is in your responsibility. So it's an expensive asset to construct, a very expensive asset to maintain, it's expensive to dispose of, and it's very expensive to neglect. Sorry, these slides are literally going to be running as I'm speaking. So in terms of asset management, it's a fairly simple concept. It's about getting the value for money out of your asset through effective usage and management. In terms of pavement, it's about designing for what you're going to use, what you're going to need. So essentially, it's about knowing what your traffic requirements are going to be. It's about carrying out the proper studies, knowing what demand is going to be there and how you're going to effectively use that over what sort of a time frame. It's about choosing your materials that are going to be effective for the environment they're working in. They're going to be effective for the usage, and that can be. And these days we need to be conscious about the recyclability of them as we move towards circular economies. In terms of asset management moving forward, then you also need to regularly assess your pavements to identify how they're performing, see what locations are under distress, determine what the rates of distress are, and what remediations are needed and when. Timely intervention is critical. An intervention after 5 years could cost half as much as an intervention after 6 years. So it's a matter of finding out when you need to act. So it's all about the optimization of materials and resources. And then afterwards, you can also go back then and assess how effective your interventions were, what worked this time, what's going to work the next time. So I'm going to highlight some critical documents that are in use here. The majorities are these from national roads. As you see there, I'm not going to list them all out, but in terms of doing PARR reports, the critical ones to know are HD31. Sorry, I'm going to reference the old currency. Effectively, they're now referenced under these guidance numbers, AM, PAV, etc. But most of us will know them by the old currency. So HD31, which is the Pavement Asset Repair and Renewal Principles, which is the main set which sets out the guidelines for compiling a PARR report, which is the Pavement Asset Repair and Renewal Report. Effectively, what you need to do to carry out the pavement evaluation and submit that to the TII. The second one to need to know would be HD30, which effectively is the gateways to getting a PARR report approved, what the TII inspectors are looking at. You need to be conscious of HD28, which has now been split into two separate documents, which is in terms of your skid resistance, which then ties back into HD36, your surfacing materials, your correct choice of surfacing materials moving forward. And likewise then HD37, the selection of your bituminous mixtures, and which are your appropriate bituminous mixtures and how you compile them all together. I won't go through the whole list, but there's some guidance towards it. But one thing I will advise everybody is to sign up for the TII's updates because they're constantly upgrading, they're constantly innovating, and the process and the materials are moving forward at such a speed these days that if you're not signed up for their updates, you'll be left behind very quickly. In terms of the non-national network, those same documents do apply in a lot of cases. However, I will highlight this again later on, that in terms of the Series 900 documents, the bituminous materials, there was a note came from the RMO and the Department of Transport back in 2014 that you shouldn't use Series 900 post 2014 for non-national roads. So effectively because of the use of SMA materials, there's the SMA is not as effective with low-speed roads, mainly because the polishing of the outer layer film does not get removed quick enough. Other documents that we'll use there would, of course, be the Orange Book, as we all know, to the Guidelines Adaptive Overlay on Rural, Regional and Local Roads, and the Guidelines for Rehabilitation over peat. I'll also throw in there an old document, but a very efficient document, which is the Guidelines for the use of falling weight deflectometer in Ireland. So in terms of asset management, the two major processes ongoing in this country at the moment are the TII's PAMS assessment, which is Pavement Asset Management System. And in terms of non-national network, is with the RMO's assessment, I can't remember what it's called, sorry. And then the annual PCI 1 to 10 ratings, which any local authority engineers would be very familiar with. One thing I will draw your attention to there is Stephen Flynn gave an excellent presentation to the IAT there about a month ago in terms of how the RMO gathers the data and how to use it. If anyone has any access to the IAT database, I'd highly recommend watching it back. So we'll focus mainly on the TII's PAMS system. This was brought in 2012 to effectively manage and to effectively ascertain how the pavement is performing nationally across the entire network over a period of years, where it's deforming, where it's under distress, where it's sorry, my line cut out. Sorry, my screen went black. Okay, back. Sorry. So effectively, effectively to manage how the pavement is performing from year to year. You can then identify locations of the stress, rates of the stress, and determine your timely interventions. It's carried out on a series over a series of criteria. As you'll see here, your roughness index, your IRI, your profile variance determines your root depths, your levels of cracking, both alligator and longitudinal, raveling, your profile depths, your characteristic SCRIM coefficient, which would be your measure of grip, and then your gradient crossfall and your surface types and pavement thicknesses are determined using a GPR. This is a typical strip map. When the TII carry out these assessments, each carriageway lane of each national road is tested annually. Sorry, each route is tested annually in opposing directions. So I'd say this year the section of the N2 might have been tested northbound. Next year it'll be tested southbound. So if you're carrying out data analysis based upon PAM's system for the TII, you need to request at least 2 years worth of data so that you have data for each lane. It's worth checking possibly against previous year's data as well. So you might be able to identify rates of deterioration over the particular section that you're looking at. But the section that you're looking at will have been highlighted to you by the TII because of its rate of deterioration and because of its critical performances. This here is an example of the N2 in County Monaghan. And as you can see, the overall structure didn't seem to be performing too badly. However, there was substantial raveling and there was substantial levels of cracking showing over the first couple of 100 meters. You also then, if you look at in terms of your left rut, there was zones of rutting occurring outside an entrance to a factory. So you could easily split this into areas of pavement performance. Generally, when you're looking at these, what you'll do is you'll then look at the chainage across the top, which is deep chainage. What you can do if you're working on a site-specific scheme, you can correct that to your own site-specific chainage. Mark in your chainage identifiers, your landmarks, your junctions, your houses, your roads. Just find out, make yourself familiar with how this lies on the ground, so that when you go out and you're looking for these distresses on the ground, you know where you're looking for, you know what's happening. So say that if you look at the left rut, there's that bulk of red on the right hand side. That was at the entrance to an industrial unit of a concrete factory, and the road was rutting there. It also had substantial increase in longitudinal and transverse cracking there, but you can see that building up on the approach. At that zone, we were coming off a bridge abutment and the road was heavily distressed. The one thing to watch as well, that the crack testing, which is carried out with the laser crack measurement system, it was carried out last year, but it wasn't carried out for a period between 2017 and 2019. So if you're looking at data from 2019, you might not have current LCMS data. So cracks you see on site might not show up on the LCMS. You might also want to be conscious that joints might not show up on the LCMS, especially your central line joint. Joints will show up as cracking. So your centerline joint, if you could have no cracking on the carriageway, but your centerline joint could be in a very poor condition. So it's treated as a crack, which effectively it is. But just to be conscious of that moving forward, that you're not just looking at wheel track cracking, you're also looking at joint cracking. So here's where the data is collected from. So your profile variance, your roughness, your rough depths are all collected by the road surface profilometer. I'll show you a picture of that in a second. As I said, the cracking is collected by the laser crack measurement system, which is a laser mounted measurement system, which sits on the back of the RSP. Your grip testing, which is carried out with the SCRIM, which is your SCRIM coefficient. And then your lower levels, then your surface type and your GPR carried out by visual inspection, and your GPR coring. The GPR, I don't think it was carried out since 2013. It's quite a substantial amount of work to carry out, but it gives you good guidance on terms of a national network, what you're doing. I wouldn't base a design off the GPR that you're getting from the PAMS data. If you're using GPR, you'd want to get more site-specific GPR data carried out. So this is the SCRIM, the sideways force coefficient routine investigation machine. This is the machine that's currently in use in the Irish networks. It's operated by PMS Limited. So this will travel every route, every national route in the country annually, and do quite a number of the non-nationals as well. It's, as I said, as part of the PAM system, each carriageway lane is done in alternating years. And what it's doing is it's traveling along at a constant speed of 80 kilometers. And a jet of water is squirted out in front of a wheel, which is traveling at 20 degrees to the direction of travel. So that wheel is constantly trying to correct itself, constantly trying to move forward. And by measuring those forces, those corrective forces, you can determine the grip on the road. There are other ways of determining grip using, say, a grip tester, or getting down on your knees and using a skid pendulum. These have been kind of phased out, but they are still in use on some network routes. The skid pendulum is frequently used for post-construction testing, so be conscious of that if you need to have testing carried out. This is the road surface profilometer. And like you all might be very familiar with the old straight edge and ruler measuring to determine rough depths, and likewise the sand patching for profile depths and for texture depths. Thankfully, this can all be done now easily at 80 kilometers an hour using the lasers on the front of the machine there. You can see that rough bar that sits in front. That can measure at road speed how those pavement characteristics. The other thing it also picks up is, on the basis from those, is the International Roughness Index, and that's a determination of your comfortable ride speed relative to the pavement performance. So you can see there what the breakdown of that. Sorry, I want to thank Dr. Kieran Feehan and Ray McGowan for this graphic. Sorry, I'm not getting my words out very well today. So just looking back, when you're determining your pavement evaluation method off the PAMS data, you need to then look and determine where your locations are of the stress. How are you going to evaluate these? How are they performing overall? Is the stress that's occurring structural or non-structural? So the next step, sorry, here's one last step this is the equates then in terms of non-nationals. This is your 1 to 10 rating for your roads. Again, this will be more familiar with non-national, but this is also determined. This can also be determined from the RSP. It's your overall number of defects relative to the number of defects in a square area. And sorry, that's after going again. Sorry, now back again. Yeah, sorry, I'm just typical when you actually go to do it, you're having IT issues.
Yeah. No, it's fine.
The next step on from moving from your PAMS data is your visual inspection. So many people will get their PAMS data and straight away be out and order their FWD assessments and their coring. Don't. Go out, get familiar with the site. Identify where the stresses are, what the environment is like. Go and see what's happening in the general proximity, what industry is happening in the area. Is the area that's causing the stress on bogland? Is it on embankment? Is there a farm access there where people are cutting in? Is there a historical build-up where the road might have settled previously? It's just very conscious. It's very important to be conscious of these moving forward. These also then work towards the PCI ratings in regional and local roads. There's a huge range of the stresses which can be worked out, which you'll all be familiar with in terms of rutting, raveling, different types of cracking, delamination and potholing. There's excellent photographs of all these and how to identify them in the back Appendix G of HD 31. So I won't show you the images there, but if there's time after the questions, I might. But that's worth going back and referencing and getting familiar with before you go out on site. It's quite a hefty document to carry on site, but it would be worth doing. They used to use windshield documents which will show you the stresses so you could rate per area. But if you're familiar with them from the back of Appendix G of HD 31, you'll know what you're looking at. So as I said, identifying these areas of particular stress can allow you to use much more efficient use of your structural testing techniques. So that when you go to hire your FWD, you know exactly what you're asking for and you know exactly where you're asking for it. So carrying out a visual inspection. In terms of doing it for a PARR report specifically, there's very specific guidance for this from HD 31. The first few items you see listed there must be included. So there must be a description of the carriageway pavements, footways and cycle tracks. And it's not mentioned there, but you should also include your verges there. It covers grates, frames and boxes. Now this usually means the ones that are in the carriageway, but if they're very obvious in the verges, I'd mention them as well. Likewise, then your curbs, edging and preformed channels, that's any concrete edging on the edge of the pavement. This is critical because that could curtail the depth of overlay that's feasible for you. Your road drainage, including your outfalls, the biggest enemy of a road is moisture. So if you've adequate drainage, mention it, see what type of drainage systems you have there. Are the drainage systems in distress? Are your gullies blocked? Is your French drain overgrown? That's so often the main cause of distress is moisture and just moisture buildup due to poor maintenance and negligence. And that could, if that was a cost-effective and timely intervention, you could save yourself a fortune in the long run. Also be aware of utilities. So an awful lot of these seem to be duplicates of each other. So utilities, again, not just the covers and grates that you might see along the road surface indicating underground utilities, but also overhead utilities. Who else has an interest in the network? So you could be looking at air, Bord Gosh, the ESB, the water services, the sewerage systems. You need to be conscious that while you're about to do a nice new pavement overlay job, are the ESB going to come along in 6 months' time and put down a new master line or master cable? So be in contact with the utilities as you go along, as well as getting the mapping from them of where their utilities are relative to your site. What are their plans? Just make sure that you're not being too premature with your works. And then traffic, of course. Traffic, just to give you an idea of what's actually happening in the area in terms of industry, in terms of commuter usage. It's not as critical to the PARR report itself, but it will be critical in terms of doing your actual design, that you know what the typical usage by traffic in the area is. Other signs which are not, other features which aren't mentioned specifically in the PARR report, but you really should keep an eye on, are your signs and roadside furniture. If they're outdated or if they're causing an issue, just make note of it. They mightn't come under the PARR itself, but by putting them in the PARR, you could be highlighting them as something to be corrected. And generally, signs will be corrected as part of a PARR scheme. Your VRS, vehicle restraint system, or your safety barriers. Again, these are currently being assessed independently by all around the national network. But if there's issues of it that you spot on site, make note of it in your visual inspection, because as well as possibly this being an opportunity to bring it to the TI's attention, the height of a VRS, or the safe working height of a VRS, could very easily limit the height of overlay you can put on. So be very conscious that if you need to put on an overlay of 100 mil, is that going to impact upon the safe working height of your VRS? We've been caught out before where that was neglected, and it can be a very expensive thing to correct. Roadside memorials, this comes in under your traffic collision. So your collision data will be collected separately from the RSA and from the TII's own collection system. But if you happen to come across roadside memorials, it's a very good indicator that something has been happening there, especially if there's a cluster. There's something going on there. And more often than not, this is a geometric issue and it's outside the scope of a PARR. But the advantage of doing the visual inspection is you can find out before going out further, are you doing a PARR? Do you need to go do a minor improvement works or major improvement works? Is a PARR sufficient? So this is something to consider before you actually go any further. Likewise, then your verging and your fencing. Typically, fencing might be corrected as part of the PARR report, as part of the PARR scheme. So see what's happening in the area. Is the fencing adequate? Is the fencing modern? Does it need upgrading? Is existing fencing going to create a safety hazard? This could be your opportunity to correct it. And likewise, IAP sites. These, let's say your Japanese knotweed. If you're working in the area, you cannot disturb these. So if you're just something to be conscious of, make note of them, even for your own records as you move forward. So in visual inspection, how to go about it. So scout out your location, go check Google Maps, the OSI, and likewise check your utilities mapping, air, ESB. They'll give you an idea of where their utilities are relative to your scheme, both overground and underground. Also knowing from your maps, you can safely determine where your start and finish locations are. You can identify safe places to work, safe places to park, know any hazardous locations where you kind of need to stay off the road. And likewise, hidden things like drains and culverts frequently pass on the road that you mightn't be aware of on site. But these could have serious implications for your FWD. If the FWD is carried out on a culvert, that'll give it a distortionately high reading. If you know that there's a culvert at that location, you can discount that reading, or let the FWD operation know that you want that reading discounted. Just simple practical things as well. Pick your day. So your ideal scenario is a dry day, so your surfaces, your conditions are dry, but not long after a period of rain so that the moisture is still in the cracks. It just makes them that bit easier to see, especially things like hairline fractures and surface cracking. It's so much more easier if there's a bit of moisture lingering. The time of year is very, very critical. So for safety reasons and just for visibility reasons, you don't want to be working in exceptionally poor weather. But likewise, if you're going to the peak of summer and you've overgrown verges, they're going to be hiding your utilities. You're going to make life much more easy, much more difficult. You mightn't be able to stand in safely, and conscious as well that you don't want the sun in your eyes when you're taking photographs. Likewise, you don't want the sun in the eyes of drivers as they're approaching you. They mightn't see you. And like you want to pick your time so that you're not battling to get home and get finished before sunset and you can't take any more photographs. What to bring? So again, it seems obvious, but a map with the chainage on it and a good camera. As I've said it fairly clearly there, phones are good, but if you have something with a decent zoom lens, it can save you having to actually stand on the road. You can operate from the verge. It's critical for your health and safety. Bring your PAMS data. Bring your PAMS data with the chainage marked on it, with your identifiers and your locations marked on it so that you know where you are and you know when you identify a failure or a distress on the site that it has been picked up or not picked up by the PAMS. And you can make note of that and cross-reference as you move forward. And this will also be critical when you go to get your FWDs, that you can highlight these locations for closer analysis. Tape measure, it might seem outdated, but if there's exceptional cracking or exceptional depths of delamination, you can just get a measure of it, literally get a measure of it so you know what you're dealing with. And it seems obvious again, but no, it shouldn't be lone working in these scenarios. So bring a second pair of eyes, not just to somebody to watch your back, but also as a second opinion that you're both seeing the same thing. And it's always good to have these discussions on site, because what I might see as hairline fractures, somebody else might see as a sign of deep structural cracking. And if there's any ambiguity, you have the opportunity when you're hiring your FWD to go and get that checked out. And of course, something to record your findings is what I'll also be able to bring. So here's a sample survey sheet that we used to use in Westmeath County Council in the NRO specifically. So as you see on the left-hand side, this is a bit of an overkill to be fair, but we'd mark in the time of day, the survey date, who was on site and the location, the chainage that we're looking at and specifically, the lane you look at, then the critical feature. So these come back to the features as highlighted in HD31, what the condition of that defect is and how we describe it. And then if we have a correlating image, we'd stick the image number in there. Excuse me for a second. That just allows you to tie your photographs back as you move forward. And how to go about doing the visual inspection for a PARR report. So when you get on site, get familiar with the site and try and, using your PAMS data and what you're seeing on site, try and group the section into homogeneous sections of homogeneous performance of characteristics. So this section, so the first 200 meters has HRA surfacing, it's in good condition. The second 400 meters has HRA surfacing, but it's heavily raveled and there's a start of a curb. Those would be two independent sections. It just makes life easier that when you identify what the typical condition of each characteristic is, you can make that note as a typical condition, and then you can focus on those features that are not typical to the condition. It saves you having to go and detail every single feature, every single crack. If the entire section is heavily rutted, heavily cracked, you don't need to go mention them all. But if there's a 10-meter section in the middle of it that's of an otherwise good road that is heavily cracked, then mention that. Photograph everything. It's just easier when you're there to get the photographs than have to go back out on site. And when you're photographing, just be conscious to photograph the element that you're looking at, so the particular crack you're looking at, but not just it. Try to get its scope, try to see how it's sitting in its overall environment and how it's approached by drivers, because this is good not just for your own records and for the PARR report, but also for your memory when you're writing this down back in the office. You see, okay, but here's the cracks all start blending and looking like each other, but if you can show each photograph in its context, in its environment, you'll remember which one is which and where it lies on the site. Don't be afraid to make notes in your maps and your PAMS data. Don't be afraid to get out the measuring tape. And again, as I said, don't get bogged down in repetitive fine details. And I'm one to talk because I always do. So here's an example of a visual inspection that was carried out in County Louth. So as you see here, this was the first 620 meters. This was a 2-kilometer long section that was split into 4 or 5 different segments. So we identified our typical condition over this first 600 meters. As you'll see, it was a HRA surface, heavily oxidized and aged, bit of raveling, cracking along the centre line joint, road markings. Some of them were an unusual texture that had kind of bubbling on them. And then in the second column, then we made note of the notable features. So highlight your centre line, highlight your joints, highlight your centre line joints, highlight any accesses or junctions that are unusual. So bituminous junctions. If you have a wealth of agricultural gates, I wouldn't mention each and every individual one of them, but I would highlight that there are a number of them, and then just focus on any of them that are in particularly bad state or any of them that are causing distress to the pavement adjacent. So likewise, then any unusual joints or construction cracks, something this particular aspect here, if there's a large patches of fatting up rubber, that was from where a vehicle got burnt out. We later found out from the RSA data. These little things just add up in terms of your footpaths and cycleways. Obviously, this is a rural aspect, so there wasn't. So we made note of what condition the verge was in and the boundary walls. On one side we had a boundary wall, and on the other side we had absolutely nothing. There was a drop into a ditch. So we made note that there was a drop into a 2 meter wide ditch, but no VRS in place, because there was VRS further on. And likewise, then in terms of your covers, grates, and manholes, what condition are they in? What's likely there? You can go into greater detail in your utility section, but just where are the covers, grates, and frames? Are they in the carriageway? Are they in the verge? What condition are they in? Keep an eye at this point as well on cat size. Are your cat size loose? That could indicate that your pavement is degrading around them. Obviously, this curbs, edging, and channels was left blank because there wasn't any. Drainage issues here. Along this stretch was mostly over the top drainage. You will have locations where you have French drainage, or you'll have gullies and grates with curbing. So just make note of them, what condition they're in, and is there any blockages? Are your road cuts clean? Are your drainage channels clean? Doing the PARR report is doing the PARR is a good opportunity to get these corrected. So as I said, utilities, not just underground but also overground, and check. It won't so much matter with your visual inspections, but when you're doing the actual PARR report, check with these utility companies, have they got future plans for upgrade, or do they want ducting included? Because if you're ripping up the pavement, it's a good chance to put in a duct. Then, as we've included other features along the way, so again, we mentioned numerous agricultural accesses, domestic accesses. You only highlight the exceptional ones as being different. You see here we've made a note in the VRS. In this case, it was generally in good condition, but the barriers were to the old standard where they slope down. You don't need to go into much detail than that, because as I said, these are all being independently assessed. If there was major damage, if there was obviously a vehicle gone into it, make note of that at certain locations. And at the very last slide in this particular point, you can see there was a roadside memorial there. So check back again against your traffic collision data. Was there a reason for that? With most of these times it's driver error, but if there was a frequency or a cluster, it might be worth something that you need to look at in terms of your skid resistance or your geometrics. So once you've ascertained on site what's happening, now you can go get your structural assessment carried out. Figure out what's causing these failures, what sort of life has the pavement got left, what sort of work do you need to do to make the pavement last as long as you need it to do, and is the cost of getting it there justifiable relative to the traffic uses that you have. So in terms of structural failure, you'll have subgrade strain, effectively it's bottom up, which means your subgrade is starting to suffer, your subgrade is having an effect on the pavement. So you're cracking, or you'll have degraded subgrade, degraded granular layers, and you'll start ending up seeing rutting and cracking and settlement. Say overlay fatigue then, which effectively is top down, is generally driven by just the age and wear of the overlay, or else an inadequate total bituminous thickness. So you'll start seeing the settlement again of the pavement, but it won't be as direct as a rut. You'll start seeing differential settlement and cracking. Of course, then raveling is one of the most critical examples of this. It's not exactly structural, but it'll tell you that your pavement is aged and oxidized. And then cracking. Cracking is a curious animal in terms of its occurrence. It can indicate a range of things, like transverse and longitudinal cracking can be a sign of lateral settlement across, or differential settlement across a bog, but clusters of it can be signs of joints in concrete. So it's a matter of looking at your environment and seeing what's happening as a result, what could be causing this cracking. So your structural assessment, the main routes of doing it in this country are your FWD, the falling wet deflectometer, going out and taking cores and determining what sort of pavement structure you have there. So coring with, or using a GPR, doing dynamic cone penetrometer testing, or taking slit trenches. Slit trenches can't be got away from. We try to keep everything non-invasive, but eventually you are going to have to take a core, take a slit trench just to calibrate what you're getting otherwise. And as critical as anything else is your traffic assessment. If you overestimate your traffic, you're going to over-design your pavement. If you underestimate your traffic, you're going to under-design your pavement. Getting it correct, or as close as possible, is critical. You're never going to get it exactly right, because there's too many unknowns. You could design a perfect road to last 40 years, and some Egypt could go down it next week in a track digger. So it's a matter of just trying to get it as right as you can at the time. So we'll just look at the FWD first. There's a good schematic of it, and again another nice schematic of it. So the FWD applies a standardized loading to the pavement through a loading plate. In Ireland, it's typically 40 kilonewtons, which would be the equivalence of a load of a single wheel load, or a double wheel load under an 8-ton truck. The loading is imparted directly down into what, if you see that nice swoop there, is called the bowl of deflection. And these sensors then pick up the seismic reaction of that, or these geophones. The spacing of these geophones in Ireland is typically at 300 mil centers. Oh, what's happening here? And the spacings are important because the differences of the reading from these sensors tells you how the pavement is performing. So if I look back one shot here, directly under the pavement here, that's your D1. That's the overall structural capacity of the pavement. The next line then is the, oh, actually written here, sorry, the D1 is the overall, that's directly under the load. So that's your overall pavement structure performance. The next one you need to be conscious of is the SCI, which is the surface curvature index, and it's the difference between the D1 and the D2, which is the next sensor 300 mils away. And this is an indicator of your overall structural upper layer performance and how the load is spread from one layer to another. And this is very, very applicable because the Orange Book, so the guidelines for overlay on non-national roads, puts a limit of 250 microns for an SCI. If you cannot safely overlay with bituminous only material when your SCI is over 250, and the TII documents don't contradict this. Well, rarely on a national road would you get an SCI above 250, but effectively, if you overlay on locations where you have an SCI greater than 250, you're going to have a premature failure. The load spread is not there. Anything you're putting on is going straight into the subgrade. And your D7 then, your last one, is the indicator of your subgrade performance. Sometimes it's referred to as the D9. The naming isn't important at all, but the location is, this should be 1800 mils from the loading. And this is a point I want to stress here. There are numerous operators operating around the country, and some come in from the UK, and these sensors are set up at different positions. HD31 outlines specifically where these sensors should be. And the D7 should be recording at 1800 mils from the center. Some recording it at 2100. And it's just, that would give you a performance of, that would indicate that your subgrade is performing 20% better than it is. So it's critical that your subgrade performance indicator for your D7 or whatever it's called, but whatever geophone is recording it is at 1800 mils from the loading as per HD31. Now, this is not overly critical on a well-designed, well-engineered national road. However, if you go to an older legacy national secondary or into regionals and counties where your subgrade is in play, this starts becoming very critical. So it is something to be conscious of. Make sure that those sensors are in the correct locations. So I just look again at the SCI. As I mentioned, it's the D1 minus the D2. So this is the load spread. So as you apply a load directly upon the pavement, it should be evenly spread through the pavement, through the granular, and so there's very little loading on any one point of the subgrade. If you have a poor SCI, that load is not being imparted correctly through your bituminous and granular layers, and it's going directly down into the subgrade. That will create a premature failure. So be conscious, if your SCI is greater than 250, you're not looking at a bituminous only overlay. You're either replacing those materials or you're building back up with, effectively you're sacrificing this bituminous layer and you're building back up with a new layer of granular with a new layer of bituminous above it. So the HD31 again gives performance criteria based upon these D1, SCI and D7s. I'll just show it there briefly, but I'd recommend go back and read it. Sorry, this is the old one. This is from 2015. This was updated last year. So these are also the performance indicators. Now, again, if you're comparing these like for like, this is at 1800, not 2100. So just be conscious that it's 1800 it needs to be at. What's happening there? Sorry. So here's these are the typical plots you get back from your FWD survey. So you'll see a D1 at the top, and this is a typical plot for a national primary road. So you have the changes in construction are clearly visible, so you see where your pavement type changes, and likewise the changes in overall structural performance. In this zone here between change 500 and 1000, this is where we were starting. This is the same section I showed you the PAMs for over the first 100,000 meters. So along this direction, this is where you're starting to see the deterioration of the pavement, and this was also correlated to a reduced overall pavement thickness. So in this case, the performance was driven by the upper layer pavement performance, because you drop from an overall pavement thickness of this along this stretch of 220 mils. Along this stretch, you're looking at 170 mils of bituminous. Along the latter end, that increased back up to 250 mils, and you can see that in the pavement performance there. The SCI follows a very similar plot to D1. That then indicates that your performance is being driven by upper layer pavement performance. And again, you can see that clearly because the D7 plot, while there are some slight trends, it looks nothing like it at all. The one peak here, which only corresponds to one peak there of where either the existing pavement is causing distress to the subgrade, or you have a particularly low point of subgrade which is distressing the pavement. In this case, that was a junction that the jointing hadn't been carried out correctly with, and the pavement and the subgrade had become distressed. This is a more typical one for I know this is taken from HD31 itself, but this is actually a more typical one for a regional road where the subgrade is in play, and you can see the similar plot plays out through each plot. So the D1 and SCI are affected by your subgrade performance. And again, I can stress this is why it's important to have that D7 in the right place so that you're getting these profiles and that they match up. So when the FWD analysis is carried out, they'll segment it into manageable depths, so you can actually carry out analysis based upon those. And as you'll see here, that this particular aspect they've shown the split into 600-meter sections. The 600 meters, another 500 meters, and these are based upon homogeneous behavior, so that when they go to do the design, they can design for sections of length as opposed to designing for every single location, which would not make it constructible. So when you go to hire your FWD, it's very important that you apply your knowledge. So the FWD survey is typically carried out at specific intervals, so 50 meters or 25 meters. But if you have pre-identified these specific locations of failure that you want tested in greater intensity, make it known to the FWD operator in advance. That will make life so much easier for you. You will have a wealth more data to actually ascertain what's going on, as opposed to carrying out testing at these specified intervals. I'll show you an example here. This is a section of the N2 again. And if I look at the zone here in red, this is quite a short section. And if this testing had been carried out purely at 50-meter intervals, we would only have had 4 tests per lane in this section, which was not adequate at all, considering this section was extremely distressed. There's layers of alligator cracking, you had delamination, you had signs of rutting, but otherwise the pavement around it was in pretty good state, and it was only really in a 200-meter stretch in the middle of this that the pavement was at its worst. So it's conscious that if you just let the tester run through that at the typical intervals, you could miss some of the worst of the pavement and completely under-design that section. Or else this section could be used to design the following section, and you could have a complete over-design of the following section. So here's an example of that section tested at 50-meter intervals compared to how it was tested at 10-meter intervals. And you can see if you look at this zone here between 100 and, sorry, this isn't that section, it's another section, but it's the same event, that if you look at the level of detail you're getting testing at 10-meter intervals. Now, 10-meter intervals is extremely evasive FWD testing. You're going to be a long time on site. As I see here, 22 test locations compared to 110. But if you've been on site and you're familiar with the site and you know where you want your testing carried out, you can go and say, well, I want 50-meter intervals up to 100, up to chainage 100, and then from chainage 100 to 150 or chainage 160, test at 10-meter intervals. That way you get the best of both worlds. So you can pick up all these extra data points in between. And likewise here, that were missed. This point here, if you look at the previous one, was completely missed in the 50-meter intervals, whereas you had 3 or 4 points here on both lanes that were proving critical in mixed interval testing. So as it says here, if you can target specific areas of distress for increased frequency testing, you can provide a much better understanding, and you get much better value for money out of your FWD test, and you won't have to go back and try and figure out, okay, well, my FWD has come back saying I have no structural overlay requirement, even though I'm seeing these zones of frequency of distress. You can figure out why. So I'm saying, don't be in a rush to get your overall FWD overlay and inlay requirements. It's based on homogeneous sections, but these sections might be conscious that the sections that the FWD analyst is giving you mightn't be practical for you, the designer, or for the site conditions. You mightn't be able to overlay here. You might be curtailed by curb heights, by approaches into town. Likewise, you mightn't be able to do full depth inlays. You could be crossing a bridge. But be conscious of what you can do, and considering reviewing those deflection plots in advance of getting the overlays back. When the testings carry out, let's say, can I get the plots just so I can review them myself and see, are you in agreement with the analyst? Or do you require different segmentation? What's going to work compared to, like, you're never going to have your visual inspection segmentation matching your FWD. You can, but it's very rare. But if you require extra segmentation so that you can slot one into the other, that can be very doable if you speak to your FWD operator in advance or during the process. It shouldn't be a matter of just waiting for the report. Engage with them while you're doing the work. And do you need an overlay or an inlay or both? Like, it's rare you'll have a section that it's becoming more and more common that inlay will be required. You will need to really move the surfacing so that you get a proper bond. And in terms of recycling material, people are much more conscious about just not burying good stone under good stone. So could an inlay be the option? If your existing pavement is structurally adequate, you might need to do a rehabilitation based on an inlay. Find out what your inlay requirements are. It's very easy to get it done, to make it part of the tender and get it carried out at the time, as opposed to realizing afterwards you have to go get the testing done and have to re-tender. Likewise, most FWD operators can also give you an estimate of the residual life of the pavement, and this can tell you how much life you have if you do nothing, which can be a handy thing to keep in the back pocket, that if the costs you're coming back are for an overlay, for the overlay or inlay for your 10-year design life are exceptional, well, if you do nothing, this is what you're getting at. And likewise, you can ask them to say, do a 5-year example. Don't be afraid to vary your design lives. So this is an example of being conscious of the segmentation. So this is a raw data site that was carried out. This is the raw data that came back from a site that was assessed by one of the operators. This is an English operator that carried out this one for us. And this is the segmentation that they proposed. Now, there was logic behind it, because there's an unwritten rule among FWD operators that you wouldn't segment less than 200 meters. So this section here would have been too short for 200 meters. This one could possibly have been 200 meters on its own, but this would have isolated this section. And this section here was just unexplainable. But this was the segmentation that they came back with. So we revised it in Westmead NRO, and we asked them to look at this alternatively, because when you looked at the opposing lane, this section here on the opposing lane had the exact same profile, which meant when you compared the two lanes, you had 10 data points between them that you could carry out the analysis. And like 10 data points for statistical analysis is the correct way to do it in the ideal world. But if you're the designer out on site and you have a massive failure in the middle, you need to figure out what's happening there. So the odd isolated location where you need to design for is worth designing for. It's not going to reflect on the design of this section or this section, but it will impact on the design of this section. The overall result of us resegmenting this was a massive saving on the design cost for this section here from chainage 300 to 500, and what would have been a massive under design for the section from chainage 0 to 300 and from 500 to 1000. It just meant much more efficient statistical analysis, much more efficient use of materials moving forward. So in terms of the loading on the pavement, this is where we get critical to our traffic. And you see there's a nice mix of traffic flow on the Mullingar bypass. Trucks, buses, milk lorry and cars. And cars, while they make up the majority of the volume of traffic, you can effectively consider cars a spacer between the trucks in terms of what they do. The loading from a truck is an empirical loading. It's a 4-power law to compare to what a car will do. So it's just be conscious that when you're giving your AADTs and percentage heavy goods vehicles, the percentage heavy goods vehicles is very important to have. So these kind of speak for themselves, but the correct traffic assessment is essential for efficient design and pavement assessment. And if you're carrying out counts, if you're not using TII counters, if you're carrying out counts specifically, make sure they're over an adequate period, that you're getting a good design. No point carrying out during a midterm break or over the Christmas holidays or in periods of bad weather, or God forbid now, are the conditions we're seeing now, are they appropriate to be carrying out traffic counts? Industry seems to be working, but our commuter traffic is down. Like cars, I know I just said they're spacing, but they do contribute. But just try and get appropriate periods to carry out your count over, and it shouldn't, for a national road, it shouldn't be less than 3 weeks. But to be fair, most national roads, thankfully the TI have an excellent series of traffic counters across the country. That, as well as that, be conscious of your growth rate. In times of industrial growth and prosperity, the growth rates will climb to 3%, 3.5%. In times of poor downturn, you could be looking at 2%. There seems to be constant growth. So it's just a matter of, excuse me a second, of applying an efficient figure for it. This will generally be done by your FWD operator, but make sure that you're comfortable with the growth rates that they've applied. And again, design for an appropriate design life. The majority of national roads and most local roads, you'll design your structural life for a 20-year life, which is adequate. But if you're in the middle of a town, somebody's going to come along and dig that up within 10 years. So designing for 20 years in that environment is not critical. And in fact, the TII usually won't let you submit a PARR report in an urban environment for more than 10 years. So be conscious that design for your environment too. So what then actually happens in the FWD is they carry out a process of back calculation to get to the structure, determine your overlay requirements. So they'll figure out, when you carried out your structural testing and your core depths, this back calculation process is carried out, a multi-layer linear elastic system which determines the actual moduli of the pavement. The programs to be used to carry out this out are listed here in HT31. I'll fly through this because most people, it's something that the operators will know, but the slides will be available if you need to look back over it. So typical pavement structure in a national road is bituminous and granular. There are some bituminous on concrete and some concrete roads. We won't hide them. They are out there. I'm not going to speak on them now, but if anyone wants to talk to me about them again, it's just mainly a matter of how you deal with them. In terms of, it's usually a matter of remove the concrete, replace the concrete, or build over the concrete. In terms of flexible roads, this is what you're looking at. You're either on a national road, it's usually bituminous and granular of a specific depth. If the bituminous layer is more than 75 mil, it's treated as a 3-layer pavement. If the bituminous layer is less than 75 mil, it's treated as a 2-layer pavement. Effectively means that your structural layer is carried by your granular layer, and your 75 mil bituminous is treated as a surfacing. That would be more typical on regionals and counties at the time than nationals, thank God. And as for the layers, layer than concrete layer, these must be modeled as separate layers. These specifications are laid out in HT31 as well. But be very conscious that you get your pavement layer thicknesses are correct, because as it says here, an underestimate of over 15% in a pavement can result in a 50% overestimate in the stiffness modulus. So how to determine the pavement thickness? There are multiple ways, and most of them you'll be very familiar with. So your as-built, then is GPR, the ground penetrating radar. This is a very nice diagnostic that JRD did years ago. Your cores, sampling, taking cores. Now be conscious that the core might not remove your granular material, so it'll just tell you what your bituminous layer thickness is. Also, when you're looking at cores, look for delamination. Delamination can be very critical in the terms, especially if you're inlaying or removing surfacing, to make sure that you've no thin layers left behind. So this was a nice core. It was a good depth. It was in one piece. You clearly see your surfacing layer thickness. You can clearly see your binder layer thickness, and you can clearly see your base layer thickness. If there's any delamination there, you would need to make note of that. Your DCP, dynamic cone penetrometer, this is usually used to determine subgrade performance. That's what it's supposed to be used for, but in this country, we're great at using it for testing granular performance. Effectively, this weight is driven down across, this pole is driven down by a weight, 8 kilogram hammer, which is dropped through a specific length. And as the hammer drops, the pole is, this point is 60-degree cone is driven into the ground, and effectively you can get a plot relative, the number of blows relative to the penetration. Based on that, then you can determine your percentage, your CBR, the California bearing ratio, which is critical to subgrade performance. In terms of assessing granular material, it'll tell you how stiff your granular material is, how well compacted your granular material is. But on national roads, generally you'll hit refusal straight away. It won't go for you because we get very well compacted, very good depths of granular material, and this really was designed for subgrades. That said, if you're taking cores, do your DCP. It'll give you, it's much more information than you get, because the core will not remove granular material, and it's definitely worth doing for the amount of time that's involved. Trial pits and slit trenches, that's why you can't get away from them, because the core will not remove the granular material, and the DCP, if it fails to penetrate, you're not going to know how much granular material you have there or what condition it's in. So more often than not, you will end up taking a slit trench, especially in zones of cracking or delamination, because you need to get to the point and figure out how deep that goes. Has your crack penetrated through your entire bituminous layer? Has your granular material become degraded? Especially if you're working on national roads, expect to take at least 2 or 3 slit trenches, just to be sure, just to calibrate the rest of the data that you're getting, to be sure that you're not going to sit down with the TII and they're going to say, okay, well, you've got cracking here, how deep does it go? And you don't know. Just take the time, hire out, get a contractor with a digger, take your slit trench. I know it's extremely invasive, but if you're doing the works anyway, you might as well be well informed. Now, when we go back to looking at the FWD corrections data again, once we now have an idea of our pavement model, we've carried out our back calculation, and now we're determining our overlay or inlay. So we need to assess what the bitumen is doing. And this is something that needs to be carried out, and be conscious of when you're hiring an FWD that they're doing this. Temperature correction, because bitumen is highly susceptible to temperature correction, and all designs are carried out based upon an ideal standardized laboratory temperature of 20 degrees Celsius. However, in this country, our temperatures on the pavement can vary from negative anything up to about 50, 60 degrees during the summertime. So ideally, again, HT31 and the guidelines for FWD analysis specify that you shouldn't be carrying out FWD analysis when the pavement temperature at 100 mils down is more than 30 degrees or is under 2 degrees. Over 30 degrees, your pavement becomes too fluid. You'll end up with a much lower stiffness modulus, and below 2 degrees, your underground materials, the crystallization occurs in the granular material and in the pavement, and you end up with a much more rigid pavement. So it's not representative of what's actually happening. And again, pavement temperature records are taken on the surface from the air and drilled down at 100 mils. With this knowledge, then the pavement is modelled. And again, this will just explain where it's coming from. I won't go through it, but it's modeled based upon the LR1132 models typically. There are other ways of doing it, but that's the one that's typically used. Again, this loading is applied. So you have created your model, your pavement model has been created, and a standardized wheel load is applied. In this case, it's a dual axle 8-ton truck load. So 40 kilonewtons applied. They then assess where the critical loading points in the pavement are and how that pavement has performed. And based upon that, then they look with your critical stresses and strains in the top of the subgrade and the bottom, and then in the bituminous material, and they can determine an appropriate overlay or inlay requirement. So, do you need an overlay or an inlay? Is your pavement adequate? When you apply a load, what the pavement should be doing is spreading that load evenly across through the pavement and evenly across the subgrade. If your pavement is insufficient capacity, the way to resolve that is either you increase the bituminous thickness so that you widen out this circle, that these arrows move up and you widen out this circle, or you replace these materials with stiffer materials so that that load is spread more evenly across. That's the only way around it. If you have insufficient capacity, more often than not, you are going to end up overlaying. If you can't overlay, you're going to be doing a patch job just to get as much life as possible out of it. So if you're hiring an FWD, I won't go through all of these slides will be available, but if you're hiring an FWD, this is the information you need to be providing to them to get this is the minimum information you want to be providing to them to get the assessment carried out correctly. And this is the minimum information you want to get back. So I've kind of talked through it all, and we will be making a document available on the processes of hiring an FWD for usage on national roads with these slides. So if anyone's interested in that, please let us know. But the slides are available, so it's all there. So how do you get from overlay requirements to your completed PARR? So as I said, the FWD will specify a particular overlay or inlay requirement, but there will also be a no structural overlay requirement. And it should be conscious that no structural overlay requirement does not mean that there is no remediation work done. So here's a typical example. These two sections both had no overlay requirement. One section you can see is heavily distressed. They're all heavily stressed on the surfacing. However, the actual overall road structure was adequate for the traffic that was there. This particular stretch of the N2 had, I think it was 12 MSA design life, over 20 years. So it's, excuse me, you can see that it wasn't going to last much longer, even though there was a no overlay requirement. So you have to be conscious that it's a no structural overlay requirement that you're getting back from your FWD operator. So you still need to carry out works, and you still need to carry out structural works, but the overall structural capacity is adequate. So you're effectively replacing what you have with similar depths of a better, more modern material, or more just newer material. So how do you get from this? The FWD will come back and it'll tell you your total bituminous thickness and total granular thickness required. So how do you break that down into your surfacing, into your binder, into your base, and into your subgrade, your subbase? And then you have to also be conscious in your optioneering of what else is happening on site, what depths are actually feasible. You have to select your surfacing material and determine what's the most feasible rehabilitation design overall. And again, does your traffic, does your usage validate the cost that's going to be involved? So what else is happening on site? Other things to be considered in the PARR report, and again, HT31 lays this out quite clearly. Your environmental constraints. You need to be conscious. Are you working around national monuments? Are you around any SACs, SPCs? Are you working in a rural or urban environment? These are critical because if you happen to be doing works in the proximity of these, you need to notify the appropriate bodies, National Monuments Board and the Department of Environment. If you're working in an urban and rural environment, it could curtail your operating times. If you're working in the middle of town, you might not be able to do your works during the day. That's going to curtail your design time over an awful significant period, and it will also drive the material that you can use, because some materials are louder than others and aren't recommended for an urban environment. Then more local constraints. What are your subgrade conditions driven by? Is it bogland? Are you an embankment? What junctions have you? What accesses have you in tie-ins? If you have an exceptional amount of accesses and tie-ins and junctions, are you going to get away with 150 mil overlay? Again, the proximity of the housing is going to be critical in terms of your surface selection, and the curbing and footway heights are going to curtail the depth of overlay that's feasible. The condition of your verges and fencing should be noted if fencing needs to be replaced. Bridges and culverts, both overhead and underground. You don't want to be overloading a bridge that's under. You shouldn't be changing the loading that's on the bridge under you, but also you can't reduce the safe operational height of the bridge over you. You cannot reduce, say, if you're overlaying by 100 mil under a bridge, you're changing its safe operational height. That you're not going to get away with that from the roads, from the bridges section of the TII, and you definitely won't get away from that with Irish Rail. They will not allow any change in height within 20 meters either side of the road, either side of the bridge. So be conscious of that you will not get away with an overlay around the bridge. And again, be conscious, our local improvement works required in the area in advance of the works. So as a developer just got planning permission for a 400 house estate at the north of your works, is that going to have to be connected to the water main in the next 2 years? Are you being premature doing your works before he's connected up and has cut through the road 20 times? Your drainage, as I said again, be conscious. Oh, sorry, oh, I jumped too far forward there. Sorry now. Drainage, the drainage remediation, and your VRS. Again, make note of anything that's damaged, and be conscious of the height of it and the implications it will have for your feasible thickness of overlay. Again, be conscious of your utilities, and also very conscious of is upgrades or ducting required. The geometric design is a difficult one now, which does not really fall, like the VRS and geometric design don't fall under PARR schemes. But if you miss them, they will have implications for your PARR schemes. Like if your crossfall and super elevation are inappropriate, and you go adding on 100 mil overlay onto that, you just make it more inappropriate. So be conscious of it, get at it early and figure out, are you looking at a PARR scheme, or are you really looking at a minor improvement, and negotiate that with the TII. You could have an opportunity to make slight corrections with a PARR, but if your geometric design is substantially out, you're really looking at a minor improvement. And likewise, road signs and road markings, you can upgrade and replace those as necessary. And geotextiles. Will your site conditions benefit from the use of a geotextile? Are you allowed to use a geotextile in this site? So the replacement of your surfacing. Can be quite a difficult topic for some people sometimes, but some people just prefer to overlay directly on the existing surfacing. But in almost all cases, the existing surfacing will be aged, oxidized, cracked, and heavily contaminated. And road sweeping will only do so much. And you want to get a good bond, and you want to add structural material to structural material. And surfacing has limited structural material. Aged, oxidized, and worn surfacing has very little structural capacity. So if you're adding new material on top of that, you're just creating a weak spot in the center of your pavement. You're better off just removing your 45 mil, 50 mil of surfacing, but be conscious that you're not leaving any thin layers behind that might become delaminated. So again, go back to your cores, go back to your GPR, figure out what your maximum depth of surfacing thickness there along your design stretch is, and try and design to that. And be conscious as well that, as I said here, the structural capacity of surfacing materials is limited. So if you get an overlay requirement, you can't make that up with HRA. If you say the overlay company, the PMS, the FWD company comes back and says you need a 50 mil overlay, you can't make that up with HRA alone. SMA has some structural capacity, but not enough to do it. So you're really looking at removing your surfacing, overlaying 50 mil, and then replacing with a similar depth of surfacing. So again, the selection of the appropriate surfacing will be driven by local environmental constraints, the speed and braking requirements, the strength and ability to resist permeation and deformation. This is something to consider as well. Like, is your existing surfacing holding up in your environment? Are you on a roundabout and is your HRA losing all its stone? Likewise, are you in an urban environment or in a rural environment and you're finding you're losing texture because your SMA has washed out? Just be conscious of what's happening. Is what you have there appropriate? But also be conscious as well that the TI like to have consistency along their network. So they don't like to have a 1 kilometer section of SMA in the middle of a 20 kilometer section of HRA. Both for maintenance, constructability, but also for your winter maintenance techniques. So you need to be conscious that your gritters need slightly different setups for different types of surfacing. So be conscious of that when you're moving forward. And just generally, from constructability and practicalities, you want to try and keep it to the similar kind of style and material as you have there already, just because drivers get very, very familiar with what they're used to. Now, there will be exceptions to this, and if you can validate, I'd say you're replacing an urban environment and you want a quieter stone, you want to reduce the noise in houses, definitely look at SMAs, but be conscious of the issues that are going to be there with grip and reduced friction. So, selection of appropriate surfacing. DNPAV 03023, so we'll call it HD36 out of old currency. This lays out the surfacings that are appropriate for use on national roads in Ireland. Eddie Wintlich from the TI gave an excellent presentation on the revision to this document. He's given it both to the TI themselves and to the IAT, and if those are available, if you can access them, I'd recommend them. He goes into much better detail and explains the rationale behind it much better than I ever could. But basically, it tells you what materials are available to you. It outlines the properties of each material and why you should choose them for each particular opportunity. But this is based on national roads. It is pretty much applicable to non-nationals. But I will again highlight this circular from DTAS from 2015, which has limited the use of certain materials on non-national roads. So I'll just read out here that you'll see here dense asphalt concrete is not allowed on rural roads with speed limit greater than 60 kilometers. Likewise, SMAs are not allowed on rural roads with a speed limit greater than 60 kilometers an hour. Generally less than 60 kilometers an hour, you'd be in more urban environments, so they're making use of the low noise potential of those materials there. However, over 60 kilometers an hour, you probably don't have the traffic to remove the film of SMA. It's an excellent structural material. It's got a skeletal structure that binds together very well, so it's excellent on roundabouts and places like that in terms of holding its structure. However, it's got a film of bitumen across the top that can take quite a while to wear off, and because it's a negative texture as opposed to a positive texture, you just don't get the same grip resistance as you do in a HRA. And if you're in a rural road or a very low volume national primary or national secondary, is SMA going to be beneficial? Are you going to have enough traffic to get to wear off the surfacing to get the grip out of it? Could it be a hindrance to you more than a help? So just weigh up the options there, but be conscious if you're working on local roads of this road note. And I'd like to thank Alan Lynch from ARP for bringing this to my attention last year, because it's something I would have missed completely otherwise. So determine your surface layer thickness. What thickness are you looking at in terms of surfacing? Again, your minimum thicknesses and your optimal thicknesses are driven by Series 900. You'll all be familiar with it. I'll show you a slide from it in a second. But it also requires, as well as telling you your thicknesses and the material properties, it also tells you your post construction testing and what you might need to do. So be conscious that the most recent revisions to Series 900 requires for extra testing for HRA materials, and for most surfacings now they also want to take cores for friction after polishing testing. So just be conscious of that moving forward. Consider your regulation at this point also, that if you need to make corrections to your pavement profile using regulation, can you make it up with, if you're doing a multi-layer replacement, can you make it up with binder layer, or will you need a regulation? And try and get your volumes correct, because the contractors will really hammer you on regulation if you get it wrong. Again, the guidance on the appropriate layer thicknesses is provided in HT 300 as well. So here's an example from Series 900. This is the left-hand side. You'll see the breakdown of what's expected from the stones, and on the right-hand side you'll see the product composition and properties expected from the bitumen, and again from the stones and your sieve size. What you really want to know in terms of the pavement design, though, is your optimum layer thicknesses. So if you look at these columns here, your nominal layer thickness for this depth of for this HRA for surfacing, and your minimum, and see what can you work with. So if you're along a section and you need to replace 30 mil of HRA, you need to replace 30 mil of surface dressing, but you want to replace it with HRA, you need to be conscious that you're going to be increasing your overall pavement thickness by a minimum of 10 mil, because the least you're putting on will be 40 mil. Now, unless you go for the pre-coated chippings or some of the specialist HRAs, but that will require departure, so be conscious of that moving forward. So selection of your aggregates is driven by HT 36. Again, if you want to reference back to Eddie Winterlich's lectures from last month, these were revised more recently, so be conscious that you now have extra section for urban roads or speed limits less than 60 kilometers an hour. So effectively, it's based on your average daily flow. Now, be conscious, this is not your AADT. Your AADT is for 2 lanes. This is your average daily flow per lane. So it's effectively, in most cases, it's going to be half whatever your AADT is, and that will be in terms of HGV vehicles as well. So be conscious when you're looking at these figures, this is less than 25,000 per lane per day. And then look at your event, see, are you on a motorway, non-event, approaching a roundabout? This will tell you what your PSV needs to be. Like a polished, like the PSV is the polished stone value. Again, you must be familiar with it, but it's the how long it takes the stone to polish up under certain conditions in a lab. Then the aggregate abrasion value is effectively how long will it take the stone to break down under loading, and these are the minimum requirements then for those same conditions. Again, these are both laid out very clearly in HT 26. So your selection of your subbase and your structural layers, we say binder base and subbase. In most cases, these are going to be driven by your overlay requirements. Whereas I said your surfacing has limited structural capacity, you can contribute some of your overlay thickness. You can contribute surfacing to some of your overlay thickness if you have enough of an overlay requirement. Say if your overlay requirement is 100 mil, you could potentially get away with 40 on 60, as long as you're not reliant entirely on the surfacing. But then be conscious as well that if you're replacing an existing surfacing, you may as well remove that existing surfacing, raise your pavement by your 100 mil, and then replace it with a similar thickness of surfacing. In terms of determining the thicknesses here, again, you're driven by the nominal and minimum thicknesses for each material. Generally in this country, your binder base layers are going to be asphaltic concrete, old DBM. So it'll either be AC20 for binders or AC32 for base material. And these are the minimum thicknesses you're looking at, or your nominal thicknesses. And if you know what your overlay requirement is, it's a matter of splitting that into a cost-effective basis and looking at what your structure is going to be on top of that. If you need to do an inlay, you need to determine how much material you need to remove. If you need to get to the bottom of a crack or bottom of a core, how much material do you need to remove? What are the minimum thicknesses of these layers you're going to need to get back up? And then how much surfacing you're going to need on top of that. So it's a matter of iterating, draw it out a few times and figure out what works for you. Be conscious also as well, if you need to do a full depth reconstruction and your FW operator has not given you a bituminous on granular design, if he's just given you an inlay design based upon bituminous material, and you suddenly realize you've taken your slit trench and realize you're subgraded, T-graded as well, so you need to replace your granular. Be conscious that you need to go back to the old HD25, 26 and look and see what thicknesses of granular material you need, what capping you need. So again, be very familiar with these charts. I'd say most of you are. And again, if you've done the TI course, you definitely are, and you'll be familiar with the new modern analytical versions of this. But just if you need to go doing granular designs, be conscious of this, and then refer back to the granular layer specifications as per Series 800. Excuse me a second, we're almost there. Sorry, I know I'm going on a bit. So the usage of geotextiles, again, can be quite controversial, but the usage of geotextiles is permitted, and the reasons why it's permitted are detailed in Section 7 of HD 300. And there's also specifications on them in Series 900 also. They're excellent in locations of poor subgrade performance. I've referenced 40 microns there, but that's when you want to start considering it. If you're looking at a D7 greater than 50 microns, you really want to be using it. They'll reduce the loading, they'll spread the load much better, so you're reducing the load in your subgrade. They also reduce the propensity of the pavement to settle differentially. And if you're overlaying on a bog road or bog rampart, the peat material has a propensity to settle differentially under its own right. So you need to be conscious there that if the pavement is settling, you don't want to be increasing the pavement thickness more than you have to. So you could potentially be better off inlaying and including a geotextile to incorporate it, or if you do have to overlay, keep it to a minimum and incorporate a geotextile there just to spread the load. In terms of lower layers, they're great barrier protectors to stop the ingress of water. Effectively create a raft that you can carry out your sub-base construction on. In terms, if you don't have adequate verges, if you're along an embankment and you're running out of adequate verges that can provide lateral support, it's not ideal. It can be done though. It'll take a bit of negotiation with the TII, but it can be done. It's a bit of a help where you've nothing else. Short of creating a massive embankment or retaining structures, they can hold it together from within. And they can reduce the depth of material required. It's not specific how much. Different companies will tell you how much. If you ask your FW operator, they won't determine how much you can save using your geotextile, because there's too many unknowns. But you can either reduce the depth of material slightly under caution and under negotiation, or you can get a much longer life out of your pavement, and they are worth considering in the right circumstances. And now again, they are expensive and they can be quite costly and wasteful if you're not used correctly. So I'd caution against them unless you're in a circumstance. If you're on a bog road, bog rampart, if you have poor lateral support, or if you're constructing over a concrete road, if you need to stop, they have a great propensity to stop the propagation of cracks up and down through the pavement. So you're building over hydraulically bound material. They'll stop. They won't stop, but they'll reduce the risk of cracks propagating up from the HBM and the joints propagating up. Here's the layout of the diagnostic from HD 300. Yeah, sorry. And it just lays out what conditions you need to determine do you need a geotextile. So again, I'll reference you back to that document as opposed to going through it in depth, but this is quite a good graph that the TI prepared, and it's good to have in your back pocket just for reference, that you know, do you need it or not? Can you justify using it or not? So now we've determined what our surfacing is, what our thickness is, what our binder is going to be, what if we need regulating or not. And so this is your outline design. This will be the back of your PARR report. This is effectively what we want to do. So in this case, this is one off section that was done for Leitrim County Council. So here we had 50 mils of HRA on top. It was a huge existing surfacing. So we had to remove that. It was nearly 50 mils throughout. So we had to remove that, and we were going to replace it with like. And we were conscious of not leaving any thin layers behind. So that was mentioned there, that this is a direction to the contractor as well, because you will usually use this in your tender documents. In this case, this particular section required a 50 mil overlay, so we removed 50 mil of surfacing, we replaced 50 mil of surfacing on 50 mil of AC20 binder, and then put in a condition there for regulating as required, because you'll always find when you're on site that you need to do a bit of regulating. And when you do go to like this, we're at this stage now, we're just looking at PARR. We haven't actually done the design yet. When you start doing your tender design drawings, you start realizing that you need to make small corrections here or there that you are going to need regulating. So put that in there, that you're making a cost-effective guesstimate of what your regulating is going to be, and that you can then work forward based on that. So your cost estimate, how are you going to pay for this? Who's going to pay for this? So estimate the cost for each series of the works. So your cost for your planing, for your cost for your material removal, your cost for your fencing, your cost for your bituminous binder, for your surfacing, for your base, and work through the whole lot of all the series. They're laid out very carefully in the TI's schedule for rates, and reference back to the schedule of rates, what cost the TI are getting. If you've gotten previous works done in the area, you'll know what your rough costs are for a particular aspect of work, so use that cost as well if you can back it up. If you're like ourselves in Westmeath, Offaly and Longford have developed a framework of contractors to work in the area, so as part of that they also got a draft tender of different costs, so based on that you can have an idea of what it's going to cost to get certain work done in certain counties. And again, at this point as well, don't forget to put in a cost for your preliminaries, and don't forget a cost for your regulation, because if you forget regulation, you will get hammered. So overall, to summarize the PARR report, don't forget at the end of the day, the PARR report is a proposal. This is this is what you've ascertained is the best design possible. The TI might not agree, so you'd be prepared to negotiate. And if they don't agree with you, don't consider it a criticism. Consider it that you have to go back and revise, and don't be surprised if they request further testing. And that's why it's critical to get familiar with the site first, that you know where you need to test, how much testing you need to go to get done, that you have an idea that if you need a greater intensity of FWD testing along this stretch, go get it done. Better to get it done at the start as opposed to have the TI tell you that you need to get more testing done, or that you need to get more cores done or more slit trenches done just to get to the bottom of the pavement. Do it first, build up your case profile and be sure of it. Don't be afraid to consult your TI inspector. Get to know your TI inspector, and don't be afraid to consult them as you go through the process, because if they know the logic behind your thinking, they'll contribute to that, and you'll both develop a much better proposal overall. And don't forget that submitting the PARR report is just your first gateway. Once it's approved, you've passed the first gateway. You now need to go and design it, tender it, construct it, and don't forget to review it and submit your reviews to the TI, so that finally we have a good record of what's actually laying on the roads in our country. So I think I'll leave it at that, and thank you very much. I hope I'm still in time. Am I? Oh, a bit over time, sorry.
Thank you very much, Seán. Just to say, if anybody wants to put in a question in the Q&A tab at the end of the screen there, please do, and we'll take the questions in a moment. Seán, I just want to thank you very much for a very detailed but useful document, and I do really look forward to getting the presentation. I think it will be actually a very good reference document to have. An awful lot of work went into that. It's extremely detailed and extremely lot of knowledge and work gone into it. And just want to say on behalf of myself and the Engineers Ireland Midlands region, thank you very much now for the time and effort that you put into presenting that tonight. And I think everyone will agree that it was absolutely excellent. Now it really was, and particularly as a reference document going forward. So
thanks, Jean. I just want to say as well, like, apologies, I kind of lost my run of myself in the middle of it there, but on top of this, we have two guidance documents coming with it. One is a guidance document on procuring FWD testing, what to provide your FWD tester, what to expect back from them, and what it means. The second one then will be a guidance document on how to prepare and carry out PARR reports. That's not completed yet, so well, my current workload will probably be end of March before it's ready, but if you contact the Engineers Ireland, anyone who's interested, we'll make it available to you. But the other document, the procuring of FWDs, is currently available, so we'll make it available with the slides if anyone is interested.
Okay, so Seán, just to give everybody a chance to put up their questions, I might just jump in with the closing remarks, and then we'll take the questions and answers. Just to let everyone know that the next Midlands region lecture is on the 29th of March, and we will just confirm that, and it'll be up on Engineers Ireland website if that's the case, but it's on Athlone Flood Relief Scheme, and I think it'll be quite an interesting talk there to see how they tackled it. with the flood relief scheme in Athlone. Just to remind everybody that this is a CPD event and to register it on the Engineers Ireland website, and that you have until the end of the month to register last year's CPD as well. And also just to say that the Sustainability Grand Tour is on with a lecture every week, an evening discussion every week, and the next one's on the 3rd of February, Energy Efficient Design, and the Midlands region are associated with that also. So just to say thank you very much again to Seán, and I'll just open it now to the questions and answers. So Seán, if it's okay with you, I'll just read them out and then you can. So the first question from Frank McGee. Thanks, Frank. Can you comment on the minimum removable depth of oxidized layer? Should it be full layer removal, or is 20 mil sufficient? Is there a delamination risk?
Yeah, no, there can be a delamination risk. Again, check your cores. If you're removing 20 mil and a 50 mil depth of HRA, you could potentially get away with removing the oxidized layer. I think there was a rule of thumb, usually used to be 25 mil, but just be conscious as well that there is a risk of thin layers being left behind, that you might have, when you took your core, it might have been 50 mil, but sure, the rest of it might have been 30 mil. So I would generally recommend get to the depth of your deepest layer of surfacing, and be conscious as well that surfacing has very little, especially aged surfacing, is very little integral structural value. So you don't want to be laying structural material on poor surfacing. And typically when you go look at older cores and you start seeing delamination in the lower layers, that's where surfacing, but that's where a structural layer was laid on old surface dressing or old HRA. So it's usually better to remove that or recycle it. And there's no point, if you've good PSV stone in the surfacing, there's no point burying that. Get it out, get it recycled. Don't be afraid to make use of the material. Consult the TII, of course, about it first.
Okay. Next question from Carl Kavanagh. Is it better practice to plane off surface course and replace the subsequent overlay, or to overlay X surface after using a pavement reinforcement?
I'm not quite sure I'm getting the sequence of that. It's generally better to remove your surface course either way. Just trying to get this over the X surface with using replacement reinforcement. Oh, sorry. So you either lay the reinforcement on the existing surface, and again, that goes back to the previous question. I'd be conscious about having contaminants and weaker surfacing in your pavement. Look, it depends on your trafficking. Is your cost again? Is it going to be cost effective to do this? Like, you need to be conscious of, maybe if you only have very little traffic and you're a very local road, maybe you're better off just surface dressing again. Actually, in Jeans County and Offaly, they have an excellent reputation for using geotextiles to correct bog roads. So I'd always look at what they did there back about 10 years ago. But if you're laying down geotextile and if you're replacing surfacing, I would replace the surfacing. I'd lay your geotextile on the next structural layer, tack it down very well, making sure it's very well tacked down, that it's not moving, and then build back up. But most geotextiles, there's a minimum requirement of 50 mil of cover. So are you going to get that with just surfacing? So you probably need a binder layer on top of that, and then surfacing on top. So just be conscious of what the structural requirements of the material are going to be.
Okay.
Sorry.
So next question from Oliver Brennan. With respect to the prohibition on the use of SMA on rural roads with speed above 60 kilometers per hour, and the issue of skid resistance due to low levels of traffic not removing the binder film from the aggregate, in your opinion, do the requirements for fine aggregates to have a minimum PSV of 60 in the new TII code for SMA resurfacing materials overcome the concerns with regards to the use of material on rural roads in these situations, i.e. where the speed limit is greater than 60?
They definitely go towards addressing it, but I'd be cautious to be using them. Again, if you're on rural roads, you're still bound by that road, by that note that came from DTAS back in 2015. So you couldn't use it to begin with, but I think the TIR getting towards it, but they're also be very conscious. Like, SMA, it's a great structural material, and it is a very, very good surfacing material where the traffic requires it. But if you have low traffic volumes, SMA really is a bit of an overkill. You could get away with a good surface dressing or a good HRA, but it depends. Like, again, if you're in a rural road and you're in a rural and you're coming into an urban environment, you could be justify it. If you have issues where the structure, you don't have adequate structural capacity, you could make up some structural capacity with the SMA. But I think there's too many things working against you, and I think the TII have tried to address it with that, but they also need to be conscious of the cost and the exclusivity of high PSV stone that it's getting harder to get. So if it's going to cost you that much to put it in, is it really worth it?
Next question, Joseph Ford. Great presentation. Can you advise if you can lay a surface course of HRA/SMA directly down on a surface dressing with a bond coat? Pavement testing indicated a 50 mil overlay.
You can, but I wouldn't, to be honest. Like it depends. If it's not cost effective to clean it off, you could leave it there if your traffic isn't too high. If it's a rural, or local or a county road. But realistically, you're weakening your pavement in the long term. It will become a point of distress. You're better off remove that surface course because it will get contaminated. It will be cracked. It will be aged and oxidized. The only exception to that, I'd say, generally, is if you're surface dressing, because surface dressing bonds into surface dressing, and you're expecting a short-term life anyway. And Eddie Winterlich from the TI would always reference a section he did in Mayo, where he went back every 4 years and resurface dressed it, as opposed to doing a massive structural design. And he got as much life out of it as a fraction of the cost. So be conscious of that. Do your optioneering. Like the TI have excellent spreadsheets available that will give you your do nothing, your intervention after 4 years, 8 years, for a range of different materials and techniques. Don't be afraid to request that. And if you're doing that course that I mentioned at the start, that the TI are doing with Engineers Ireland, they give you that. They give you those spreadsheets and teach you how to use them. And it's a very good idea on what is your optimum design for your pavement. What's your best way of approaching it? And don't be afraid to play around with the figures and look at your costs, see what's going to actually work for you, and does your traffic justify it?
Okay.
Yep.
From Liam, what is alternative to SCRIM where bends or roundabouts exist?
So you're looking at grip testing, and I showed a picture of it there. It's a specific grip tester. It's like it measures friction with water loading, but again, when these are all designed, most of these systems are designed for straight line testing. When you start going around curves, you're changing your parameters, you're changing your speed, you're bringing extra elements into it in terms of your torsional and directional forces. The SCRIM really is the best way to go, and it's the best comparative. And you need to be conscious as well. I think most people aren't aware that the SCRIM is actually it's a brand. SCRIM itself is owned by WMD in the UK, and any company that's operating a SCRIM has to get it licensed and tested by them. So I'm conscious that the TII themselves are trying to find an alternative way of rebranding the SCRIMs that we use here and calling it a grip test, or I can't remember what the exact name was, but we're referred to them all as SCRIM at the moment. We might be calling it something different in a year or two because we're getting away from that branding. But there are the alternatives really, short of going down on your knees with a skid pendulum. It really is a grip tester, and it's just messy. It just gets very messy. And at least with the SCRIM, you've consistent data to compare against. You can't get the same directional. They are constantly. If you talk to Roy Donlan and PMS about it, they're doing constant evaluation works on bends and at different speeds, and they're developing charts so they can correlate and correct as you go around bends and go around roundabouts and checks. So don't be afraid to talk to them and see either can they calibrate your data or correlate your data for you. Sorry.
Okay.
Hope that covers.
Question from Tom Cannon. Something else to consider when preparing the cost estimate for the PARR works, accommodation works such as house frontages and drainage channels.
Exactly.
Yes.
Yeah. No. Exactly. That's the advantage of working through the entire series that the TI give you in their cost estimate, that you can look at all these things, and it's very critical then that you look at these in your visual inspection, that you're familiar. Where are these accesses? Are you going to get away with increasing by 100 mil in front of this house? Where is your drainage going to? Does it all need to work? So it all does tie into PARR, and it's a great point to make, Tom, that yeah, exactly, all these things are applicable to it.
Okay, next question. Marinelle Papa. I'm doing a master's in research with LIT on the topic of using recycled plastic waste in road construction, using polymers as binders to replace part of the bitumen. Was this considered by TII, or would it be of interest for TII's research department? What is your opinion regarding this idea?
It's fascinating. There's constant innovation going forward, and there's so many people trying out new materials and new types, and it's especially considering our waste conscious environment, it's definitely the way we have to be going. And and in terms of the circular economy as well and building it in. And I know the TII are constantly innovating and constantly testing out. So I'd say make contact with the TII if you haven't already. I think Tom Casey already went to literally probably the best people to talk to there. Likewise, some of the people in ARP are fantastic for testing, for doing research. If they haven't considered it at all, I'd say they'll definitely, if you write them a decent proposal, they'll definitely look at it. And it is interesting, it's fascinating. I've always loved hearing about these new techniques and materials that are coming forward. So like a heel road, there are people now who are putting modifiers in the pavement that when a crack occurs, it releases a heating agent that bonds the pavement back together. And likewise, some people are putting filaments through the pavement that can be heated to rebond your bitumen. They can just add to the life overall. Like, you're still going to have weathering and oxidization, but it'll just give you better structural capacity over a long time. But definitely, Marianella, I'd make contact with the TII if you can, but put a good proposal together and sell yourself.
Okay, so the next question then is from Kieran Coughlin. He's not a civil engineer, so the answer may be obvious to others, maybe not. But why can planings not be used instead of 804, 808 in the sub-base? Is it a flexibility issue?
It can be. It can also be a contaminant issue. It's like the issues we went back years ago with the pyrite. It's the unknown contaminants. Like, we're getting to a point where the recycling of planings is getting, and testing of planings is becoming exceptional. So I'd say in coming years we'll be looking at planings being turned over and put back in, effectively flipping the pancake, as one of my PMS colleagues used to call it. Like 804 and 808 are very specific materials with very specific criteria, and once you start throwing contaminants, including binder, like the binder itself is a contaminant, once you start throwing that in there, you're changing the characteristics of those. And like, while we're innovating and moving forward, I'm not sure if we're there yet that we can get away with using them instead of sub-base. And be conscious as well, these are materials, the sub-base materials will constantly have water flow through them, so you don't want those contaminants getting into the water courses, into your groundwater. And I'm just putting on my new environmental hat now, but you just need to be conscious of that moving forward as well, that you want to try and keep those separate. And hi, Kieran, good to see you. I haven't seen you since college.
So next question is from Gabriel Dooley. When profile planing out degraded upper layers, should the design consider the nominal depth of residual layers of the existing pavement structure remaining, especially if cores show delamination?
Yes, just especially just look at the nominal layer, look at the maximum depth, look at where you're seeing delamination. If you're seeing frequent delamination, or it might be worth taking more cores, trying to determine the extents, because otherwise you could end up planing considerable lengths of stretch of section that aren't required. If you know where your delamination starts and ends, it's impossible to know exactly, but if you have an idea where it starts and ends, you can keep your planing or your greater depth planing to that zone. But unless, like, the conscious as well, if you're seeing delamination in a core that's with exceptional length, if it's over 150, 200 mil, this could also be a mechanical deformation, delamination from the core being extracted. But if it's in your upper 100 mil, upper 150 mil, it's most likely down to it is a delamination. So you want to get to the bottom of that, or else you could end up with the issues of fine thin layers planing away, especially during construction, and you destabilize your pavement before you even build it.
Okay, there's a couple more here, folks, and then I think we may have to close up after this because it is getting late, but just two ones that are coming up a bit. Is the name of the course that you recommended, Seán, the TII course?
Oh, it's the design and life cycle of road pavements. I think if you check it, I've written actually, design and life cycle of road pavements, and it's run by the TII, by ARP, by Engineers Ireland, and TU Dublin. It actually comes with credited. It's a credited course, so there's 5 ECTs, master's points, 5 master's points towards it if you do it. It's a tough course. The assignments are tough, but it's exceptional. Like, the level, the presenters they have are excellent. They really know their stuff. You get them from industry, from TII. You're getting it right across the board, and they're at the cutting edge, and they know exactly what's going on, and they will answer your questions, and they will make it tough for you, but you'll get an experience and understanding of what's going on in road pavements that you won't get anywhere else, and I can't recommend it enough.
That's good to know. And then this one, and Myrna has answered it there. Yes, the presentation will be made available, and the presentation has been recorded as well. So that's great, because I think it is going to be useful. So I'm going to take the last two now. Seán Campbell. Seán, I acknowledge you had yours up nearly the first there in the chat. With the different compounds of material across Ireland on road surfaces, what would be the reflective values for lighting on the typical road? i.e., what's the most common as it affects the design calcs on road lighting in different areas? It's info that is hard to get in Ireland. Are local authorities starting to install, or are they aware that a public lighting unit can now incorporate road temperature sensors along with gully wastewater drain sensors that can help manage water levels or blockages with little uplift in cost?
I honestly don't know, and
Yeah,
I'm conscious of
yeah.
Seán's greater expertise, Seán Campbell's greater expertise in this. So I honestly don't know, Seán, but it sounds fascinating. And again, if it's something that I think should be brought to the attention of the TII and the local authorities, because look, the more information we have, the better we can design, the better we can build, the better things can last, and the more we can recycle and move forward. And we do need to be conscious of the environmental impacts and the cost impacts, because we don't have the money, we don't have the environment, we don't have the resources we did have. And this all ties in, but that sounds fascinating. So
That sounds like a
yes,
lecture, another
it
lecture,
does. It
doesn't
does.
it,
It honestly
Seán?
does. Yeah,
Yeah.
exactly. Yeah. No, but that's fantastic. Yeah. No, sorry, Seán. I honestly don't know enough to even comment, and I wouldn't dare. But someday maybe a
I
little
know,
presentation to us on it. Be great.
yeah, absolutely. We'll hold you to that now, Seán. And then finally from Philip, can you provide a strategy or innovation in providing a pavement in excess of peat? Yes, we all want to know that. What are the lessons learned in dealing with these challenges?
It's how long is a piece of string, honestly. There are so many ways. It depends what's really going to drive it is how important is the road. Like how many vehicles are actually using it, and what can they put up with, and how much can you spend, because you could end up digging out your peat and building a massive embankment. You could end up just surface dressing out every year and keeping it tight and together over years. Offaly did a fantastic situation, say, between Shannon Bridge and Ballinasloe there years ago. No, the other side, so Shannon Bridge and Banagher a few years ago, and they planed out about 100 mil. They removed most of the pavement, put in a rafting course, put in your granular, but reduce the overall granular thickness, and then put on a structural structural geotextile within the bituminous layers to tie it all together. You get some differential settlement, but compared to what the road used to be like, it's as straight as a die. And I don't know who it was, it might have been John Mitchell or somebody did the works that time, or really, but they have to really highly commend it for how it was done. In terms of, like, there's no such thing as an average design across peat. I will recommend you're probably used to the RMOs or the department's guidelines for overlays on peat bogs, but try and keep your weight down. If you need to, don't be afraid to remove material to correct it. If you, like, say, if you've been excessively building up, maybe remove some of the material as you're going, and build back up, try and level it off, because the peat has a high propensity to distort, and it'll settle in unknown ways until you load it. You can preload, but that's more cost. You can completely remove, that's more cost. You can build up, and keep regulating and correcting every year, but it's going to be more cost. I'd say keep it simple, keep it light, and keep it to a minimum. And again, let it be driven by the traffic. If it's a national road, don't be afraid to consult the TII on it, see what they're willing to do with it, see what they're willing to pay for it. Like, you've seen situations where they've effectively built a bog across it, a bridge across it, such as the structures. But again, does the road demand it? If it's a national primary, high volume national primary, like the N1, N2, N55, maybe. If it's national secondary going just around the tip of Donegal, that is still going to be very important for the locals, but in terms of the overall usage and the cost, is it going to justify it? Sorry, I can't give you a straight answer, and I feel like there's no such thing, but see what works for you. Just again, if you can get some of those evaluation techniques down, there's way out 10 or 12 different rehabilitation techniques over a couple of years. Give yourself a 20-year design cycle. Say you're willing to treat it every 4 or 5 years and make corrections. See how much that's going to cost you for different pavement techniques, and then assume you'll have 20% settlement or 50% settlement, and see how much it's going to cost you to correct that, and just play with it and see what works cost effectively for yourself. But I'd say keep it light, keep it cheap, and keep it simple.
Okay, I think, and then Seán, as you can see yourself there, lots and lots of thanks for the detailed presentation, and people looking forward.
Yeah, I know I kept going for a long time there, so sorry, but thanks everyone for paying attention. Thanks, Jean.
Okay, thanks very much, everybody. So that'll be the end of the lecture this evening. See you at the next one.